Welcome back to my channel. In today's video we are going to see how to find intersection of two arrays, right? So let's say there are two arrays given to you, nums1 and nums2. You have to take the intersection of those two arrays, which basically means you have to take those elements that are present in both the arrays. Let's take an example here. Nums1 contains 1 2 2 1 and nums2 contains 2 2, right? So 2 is the output. Why? Because see, 2 is present in nums1 and 2 is also present in nums2, right? But you might say, bro, that is fine, but there is some other 2 also, right? 2 is there, 2 is here also, but there is some other 2 and that other 2 is also here. So ideally the answer should be 2 comma 2, but no, bro. Why? Because see, each element in the result must be unique and you may return the answer in any order. Okay, so it must be unique. So we have to take care of this thing also. So let's have a look at this example, right? So 495 is given in nums1 and 94984 is given in nums2. So the answer is 9 and 4. How? Because see, 9 is present in nums1 and nums2 and 4 is also present in nums1 and nums2, right? There are multiple 9s, but we are not considering them because the answer should contain only unique values, right? So unique values, when I say unique values, what comes to your mind? When I say unique value, what comes to your mind? It should be something like set or map, right? Map will, of course, we don't need map here because we are not storing anything like key value pairs, but we just have to keep some elements, so we are using set. So what we are going to do, we are going to find the answer and we are going to keep that in set, making sure that the duplicate element should not be existing, right? So the most brute force way that comes to my mind is, bro, let's do one thing. Let's check for all the elements. What I'm saying, let's check for all the elements in nums1 whether they are in nums2 or not. So first I'm checking for, let's say, 4. 4 is 4 is there in nums1. So let's go and check whether 4 is there in nums2 or not, right? So let's say this length is n and this length is m. I'm taking all the elements from n length and I'm going to check in this m length array whether that element is present in this array or not, right? So for all the elements, like for 4, I'm checking, is it 4? No. Is it 4? Yes. So I'm storing it some set. I'm storing it in some set. Let's say 4 I found, right? And I'm going for 9 after that. So 9 is there. So at the first index itself, I got the 9. So 9 is inserted in the set, right? Then I went for 5. I checked here. 5 is not there. Here 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 5 is not there, right? So I checked for all the m elements, but I didn't get any 5. So the answer is 4m9. But bro, what you are doing in this is basically you are going to all the elements in n, and for each element you are going to check whether that element is present in nums2, which has a length of, let's say, m. So I'm going to run two loops, int I equals to, let's say, 0 to n, and then int j equals to 0 to m. This I'm going to check. Let's say I is this pointer that is pointing in this array, right? And this j is actually pointing to all these indices, right, from 0 to m. And for each ith element, I'm going to check whether the ith element in nums1 is there in jth element of nums2 or not. So basically the time complexity will be n into m, right? So in this time complexity we can solve this, and space we are taking how much? We are taking this set space, right? Set will be having what? Set will be having unique elements that are intersecting, right? So let's say k of k. What is k? K is the maximum number of unique intersecting elements. I'm not writing it here, so that is k. But what I'm saying, bro, can we optimize this? Of course we can. we can reduce this time complexity, right? So let's look at this and observe that where we are taking n into m time complexity. See, basically for each of these elements, each of n elements, I am taking of m time to check whether this element is present in this array or not, whether nums1 element is present in nums2 or not. M is basically the size of 2, right? We are iterating throughout this array, right? So we are iterating at the worst case of m times. So bro, okay, so that's the thing. For searching, we are taking of m time complexity. Can we reduce this? Can we do something and get the answer in O of 1? Basically, this check operation, can we do in O of 1? So in which data structure we can search an element in O of 1 time complexity? In set. Not in set, in unordered set. In unordered set, we can search in O of 1 time complexity, right? So what I'm going to do, instead of iterating from 0 to m, I'm going to store all these elements in a set. I'm going to check whether this ARR of I, this first loop, whether this element is there in the set or not. See, this set is different. This is answer set. And this set is different. This is a set where nums2 elements are present. I can do the other way also. I can store all these elements in a set and I can iterate throughout M and find whether that element is there in nums1 using this O of 1 space and get the answer. So let me just show you in code what I am actually saying. See, there is an unordered set and nums1. I am keeping nums1 in set1 and I am maintaining another set which will store answer, right? Storing answer here to avoid duplicates. This is very important. Why we are doing this? Why we are taking st2? This is to avoid duplicates. And then we are iterating through the second array. This is a for each loop. So I'm checking, bro, is there this element in st1? If it is there, then insert it into the answer set. If there are multiple same elements, this answer set will make sure that the elements are unique, right? So at the end, I have to return in vector. So I'm storing all these elements which are in the set in vector called answer, and then I'm just returning it. So what is the time complexity here? What is the time complexity and what is the space complexity here? So so this operation, right? Although you might think that, bro, this is a single line operation, so it should be of 1 or something, like it's a constant time. But what I'm saying, no, internally what it's doing, it's going to all the elements and placing them in the set. So let's say nums1 is having n size and nums2 is having m size. So nums1 I'm storing in set1. So this will take of n time, and then I'm going to iterate through all the elements in nums2 which is having a size of m, right? So I'm just taking of m space here, sorry, time here, and this operation, this find operation, this in average it's taking of 1 because of unordered set. So this section takes of m time complexity, this section takes of n time complexity, and what about this thing? I am storing all the elements in the set2. What is set2? Set2 is having the answer, right? I am storing all the elements in the answer to a answer vector. So let's say the maximum, let's say k is the maximum number of unique intersecting elements. So I'm going to move all the k values to answer, right? So here the time complexity will be O of k. So overall the time complexity is basically O of n plus O of m plus O of k, basically O of n plus m plus k. And what about space? I'm taking two sets. At first I'm storing n, and in second I am storing the answers, right? So O of n plus k will be the space complexity. So that's how we solve this problem. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.